This is AP Physics Podcast. This is Chapter 11, question number 15. In this problem, we have a particle of mass m moving in a circle of radius r, which starts at this point over here, q, at time 0. And as it progresses in time, it goes around this circle, and we're looking to find the angular momentum L with respect to point P as a function of time. So in general, we have found that L is equal to I omega, but we have a new definition of this, and this is the one that I left you hanging with on the chart, and that would be that L is also equal to our radius vector crossed with our momentum vector. So R cross mv. And as m is a mass, it's a scalar quantity, it's not a vector. Our vector quantity we're looking for is v. So in order to find our angular momentum as a function of time, we need to find two things: our radius vector. We need to also find our velocity vector. Now the nice thing is, once we find our radius vector, it's easy to go to our velocity vector by taking the derivative. So really all we need to find is our radius vector, and then take the cross product. So our radius vector, in general, if it was going around a circle, our radius vector would be equal to big R times the cosine of theta in the I direction, plus big R times the sine of theta in the j direction. But we see that we are shifting, in fact, by r in the I direction, so we end up having this as our radius vector. We have r times 1 plus cosine of theta in the I hat direction, plus r times sine of theta in the j hat direction. Now in order to find our theta as a function of time, we should see that our theta is equal to omega times t, but in fact we see that omega here is equal to v over r. So we end up having a theta function that is given by the following. And I'll just fill it right in here. We have r times 1 plus the cosine of vt over r in the I hat direction, plus r, and let's see, I guess I need to close one more parentheses here, r times the sine of vt over r in the j hat direction. And that is our radius vector. Now we need to then find our velocity vector, which is the derivative of that. So our velocity vector is the derivative of our radius vector with respect to time, which means as we take the derivative of this, our term with the 1 goes away. We're left with a negative cosine derivative here, so we end up having a negative r times the sine of vt over r, and then we have a chain rule, so we have to differentiate the inside, so we will end up taking v over r from the inside, and then when we take the derivative of the other side, we will get a similar thing, plus r times the sine of vt over r times v over r. And that's in the j hat direction, and this one's in the I hat direction. Now we see that our r's cancel out here and here, and here and here, and so we're left with this as our velocity function. Velocity is equal to negative sine, actually let's put the v out front, negative v times the sine of vt over r in the I hat direction, plus negative v, positive v actually, times the, and this one I just realized should be our cosine instead, times the cosine of vt over r in the j hat direction. So we can simplify this a little more, because v times t over r, that's just omega times t. So we're left with these two functions for our radius and our velocity. Our radius vector is equal to r times 1 plus cosine of omega t in the I hat direction, plus r times the sine of omega t in the j hat direction, and we are crossing that with our velocity vector, which is equal to negative v times the sine of omega t I hat plus v cosine omega t in the j hat direction. Now I won't go through this proof with you right here because, to be honest, AP has not done a lot with actually doing cross products. So our momentum, angular momentum, is R crossed with mv. So we end up getting this right here. It's equal to m times vr, and that comes from the v's here, here, the r's here, here, and the m, which was right here. mvr times the following cross product. We have 1 plus cosine omega t I hat plus sine omega t j hat, and we are crossing that with negative sine omega t I hat plus cosine omega t j hat. And the net result, and if you'd like some help on this, you can come and chat with me, but the net result is that our angular momentum as a function of time ends up being mvr times the following quantity. We have cosine of omega t plus 1. And now the question is, what direction should this be? Well, our r was in the I and j hat direction, our v was in the I and j hat direction, so this one has to be both perpendicular to I hat and j hat, so we end up with k hat.